So alpha P, this is the passband attenuation given as minus 2 dB, and ohm P is given as 20 dB. Okay, alpha S is given as minus 10 dB, ohm S is given as 30 radians per second. Okay, so if it is given negative also, you have to take positive only, because when we are deriving the formula for n, we have considered negative values. Okay, so that is why here negative values are there, even then we have to take positive only. Okay, what is our first step? Find the n value. Okay, so this is the formula we are using to find out n value. So n value is greater than or equal to log base 10 root of 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 by log of ohm s by ohm p. This is the formula you should remember. So write 2-3 times, because the same formula, same type of formula we'll be getting in Chebyshev also. So you will remember this easily. Okay. Then what we got, n is equal to 3.37. What is our next step? N value should be rounded to next integer. So n value 3.37 you got, no, you have to round it to next integer. So n is 4. Okay. What is next step? Find the poles of the filter. What are the, how we find out the poles? Sk is equal to e power j 5k, where 5k is equal to pi by 2, 2k minus 1 pi by 2n, where k value is 1, 2, so on n. Okay, so the same 5k formula will be same for Chebyshev also. Okay, that is why practice this. If you write 2-3 times, you can remember this. Okay, so substitute k value 1, find out s1, k value 2, 3, 4. Okay, so see here it is Butterworth filter. Butterworth filter poles will be on unit circle. Okay, so for this you have to find out, since n is 4, no, half of the poles, 2 poles only you find out. The third pole, see here, the third one is conjugate of second one, fourth one is conjugate of first one. Okay, so you just observe these two are conjugate, these two are conjugate. So for n is equal to 4, only find half of the poles, that is sufficient. Okay, for n is equal to 3, so you have to find out 1 and 2, and third one will be conjugate of first one, like that. Okay, so half of the poles you have to find out here. Okay, because the poles are on unit circle. Okay, then what is next step? That write the transfer function. What is the transfer function? H of s is equal to 1 by the product of s minus sk. K value is varying from 1 to n. Okay, so what is h of s now? It is 1 by 1 s minus 1 into s minus 2 into s minus 3 into s minus 4. Okay, so you substitute this. See here, when you are combining two poles, these two are complex conjugate, no, we'll combine these two poles. So s minus s1 into s minus s4 we combined, so we get s square something, no. So similarly we combine these two. Okay, so you know, no need to combine all, you no need to multiply all. Okay, s power 4 you no need to write. So we can write only s square form, which are complex conjugate, only those two will multiply. Okay, so like this, we'll by multiplying complex conjugate terms, poles. So we got two terms, s square one term, s square one term. So s power 4. What is the order now? 4 only, no? Okay. Now what is next step? This is the filter with a cutoff frequency 1 radian per second. Ma. Okay. Now we have to find out the transfer function of the filter with the given cutoff frequency. So to do that, first we have to find out the cutoff frequency. What is cutoff frequency? Ohm C is equal to ohm P by 10 power 0.1 alpha P minus 1 whole power 1 by 2n. This is the formula. Ohm P, alpha P we know. Substitute n value also we know. We got cutoff frequency is equal to this much. What do you have to do now? Now in H of S, replace S with S by ohm C. What is ohm C? 21.38 to 68. Okay. So if you do this, we got, this is the transfer function of the filter with a given cutoff frequency. Like that, we will be designing the filter. Okay. So here in this problem, what is that given? Alpha P, alpha S is given. The values are in dB. Okay. See the next problem here. What is that given? Here it is 1 by root of 1 plus epsilon square value is given. 1 by root of 1 plus lambda square value are given. See the filter specifications are from 0 to pi here. 0 to pi. Okay. So from 0 to 0.25. Okay. 0.2 pi is nothing but ohm P, and 0.4 pi is nothing but ohm S. Okay. So So this figure you should able to draw. So here also what is that given? 1 by root of 1 plus lambda epsilon square, 1 by root of 1 plus lambda square. So from this 1 by root of 1 plus epsilon square is 0.9, 1 by root of 1 plus lambda square is 0.2. See here, this is the stop band attenuation. Okay, always the filter value will start from 1, highest value is 1, the next lowest value will be the pass band attenuation. So here is the stop band attenuation. So this is the, see here it starts from 0, no, 0, and it is stopping at 0.2 pi. So 0.2 pi is nothing but ohm p, and this is nothing but ohm s. Okay, so for once you able to draw this one of this problem, you can able to solve any such problems. Okay, so from this, what is our first step is to find out epsilon and lambda. Okay, so we know this from the problem, find out epsilon and lambda. After finding epsilon and lambda, find out the order of the filter. So what is the formula for order of the filter? So n value is equal to log base 10 lambda by epsilon log ohm s by ohm p. Okay, so from this we got n is equal to 3.34. What is next step? N value should be rounded to next integer. So n value is equal to 4. Okay. Now we find out the poles. How do you find out poles? Using this formula, sk is equal to e power j 5k, and 5k value is equal to pi by 2 plus 2k minus 1 pi by 2n, where k value is varying from 1 to 4. Okay. So just now I told you, no, find out S1 and S2. S3 is conjugate of S2. S4 will be conjugate of S1. Okay, then find out h of s, that is equal to 1 by s minus s1 into s minus s2 into s minus s3 into s minus s4, like this. Okay, then find out the cutoff frequency. What is next step is find out cutoff frequency. Then find out the filter ha of s is equal to h of s, replace s with s by ohm c. Okay, so finally we got h of s is equal to this thing. So sometimes the frequency is given. Fp is equal to 1 kilohertz, Fs is equal to 2 kilohertz. Okay, frequency is given. In that case, this Fp, Fs should be converted to ohm p ohm s. How do you convert? Ohm p is equal to 2 pi Fp, ohm s is equal to 2 pi Fs. Since alpha p, alpha s are given, we use the first formula, that is n is equal to log base 10 root of 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 by log of ohm s by ohm p. That is the formula we use. Okay, the remaining procedure is same whatever we have discussed, and we will also be getting this type of problems here. The order is given, find out, they ask you to find out the pole's location. Okay, so how do you find out this? So we use this formula. What is the formula to find out the poles? Sk is equal to e power j 5k. Since you have to find out only the poles here, see students, here we have to find out only the poles. So what is 5k is equal to pi by 2 plus 2k minus pi by 2n. Okay, so substitute k value is 1 to 6. Find out s1, s2, s3, s4, s5, s6. So if you plot it on the unit circle, since it is a Butterworth stable filter, the poles on a circle on left side of S plane. Okay, now we see the steps to design analog Chebyshev filter.